In this video we will be using a graph to write rational functions. So in this unit we've been graphing and identifying the horizontal asymptotes, the vertical asymptotes, the roots, y-intercept, etc. of rational functions. And now we're actually going to take the graphs and write the functions themselves. So these notes here give us details on the process, and we will write the factors in the numerator that give us roots or wholes, and in the denominator the factors give us vertical asymptotes or wholes. So same rules as we were using before when we were taking the function and graphing it will apply here. So any factors in the numerator that do not cancel will give us roots. Any factors that cancel between numerator and denominator give us wholes. Any factors in the denominator that do not cancel will be where the vertical asymptotes are. And remember, between the factor and each of those values, the signs will be opposite. And then this a value up front will always be the value of the horizontal asymptote or the slope of the slant asymptote. So let's take a look at the examples now. All right, now for this first example, write the equation of the function that graphs as follows. So we need to identify the major information. We have a hole in the graph at x equals 1. All right, and then we have a vertical asymptote at x equals -2. That's this vertical line right here for the asymptote. And then we have a root at 1, 2, 3, -4. So root at x equals -4. We don't have any slant asymptotes at all because we have a horizontal asymptote. So that's all the major information that we need to write this function. So this function would be f of x equals, so in the numerator we need a root -4, so that gives us a factor of x plus 4. So that takes care of the root part. We have a hole at x equals 1, so we need a factor of x minus 1 here and x minus 1 in the denominator. Order of the factors is not going to matter. So the hole is taken care of. We already took care of the root. And vertical asymptote is at x equals -2, so we need a factor of x plus 2 in the denominator. The x minus 1 factors give us the hole at 1, so that's done. The x plus 2 factor gives us the vertical asymptote at x equals -2. And the root at -4 comes from the factor x plus 4 in the numerator there. And then the only other thing we need is the horizontal asymptote, which I didn't write down, is at 1, 2, 3, y equals 3. So that means we need a 3 in the very front. So that's it for this first example. We'll do one additional example next. Alright, now for this next one, for my students, this is actually number 1 from your homework. So we need to identify the major components. We see a hole in the graph right there. So there's a hole in the graph at x equals -1, 2, 3, 4. -4. By the way, these light gray lines are just pointing to the locations and graphing in the horizontal, vertical, slant asymptotes, etc. So I think you see that that's not part of the graph. That's just there for reference. Okay, we have a slant asymptote. On this lesson, we could track it and see, but on this lesson, any slants will have a slope of 1. So the slant slope, m, I'm using that from algebra, that we denote slope with an m. So the slope is equal to 1. Next, we have a vertical asymptote at -1, so VA at x equals -1. And we have roots at x values of 0 and 2. So x equals 0, x equals 2 for roots. And that is everything that we are going to need to write this function based on the graph. So f of x equals. Okay, we have a slope of 1 for the slant, so we'll put a 1 in the front. Obviously we don't have to put the 1, but we're going to just show that it's coming from the slant here. Had the slope of the slant been 2, this would be a 2. The slope of the slant goes right here in the front. Okay, so let's do roots next. We need an I'm going to change this to an x here for this root. X equals 0 means we need a factor of x, so I'm going to go ahead and put the x there. And then we have a root at +2, so we need an x minus 2 factor in the numerator. So that takes care of that and that. The slant has been handled. We have a whole at -4, so that means we need an x plus 4 factor in the numerator and in the denominator. Those would cancel, giving us the whole at x equals -4, so that's taken care of. Then lastly, we have a vertical asymptote at x equals -1, so that gives us a factor in the denominator of x plus 1. So that would be it for 1. We handled the whole was at x equals -4, so these two factors, x plus 4 in the numerator and denominator, handled that. The slant slope was 1, so that's this 1 right here. Obviously that's implied to be there whether we write it or not. I'm writing it so that you can see that's coming from this. We have a vertical asymptote at -1, so that gives us an x plus 1 factor down here in the denominator. We have roots of x equals 0, so that's coming from this factor of x in the numerator. And we have a root at +2, so that gives us this factor of x minus 2 in the numerator. So that is it for this video.